Okay, so today's Thursday, March 22nd. Today we have to talk about solubility curves, which can be a little bit daunting, but isn't all that difficult once you understand them. We're going to use the concepts of saturated, supersaturated, unsaturated today also. This is a solubility curve. What you see if you take a look here is you see that the y-axis talks about solubility of the solutes. Hold on here, let me get my marker out. Okay, so go back to the right slide. All right, so the y-axis talks about the solubility of the solutes for every 100 grams of water. What that means is that if you're reading off of this graph, you're going to be able to tell how many grams of a particular salt or substance that will dissolve in 100 grams of water. So if in the real world you actually want to dissolve something in 200 grams of water, you have to double the figure that's read off the graph. If you want to read for 50 grams of water, you have to multiply by 1/2 in order to find out the proper answer. You can use proportional math to find for any amount of water that you like. You can see across the bottom scale here, we've got the temperature. So this is measured in degrees Celsius. What you can see if you take a look at the graph in general is that most things increase in solubility as temperature increases. The red, the dark blue, the green, all increase as you get hotter and hotter. All right. So taking a look at this particular graph, which salt can you dissolve more of at 60 degrees Celsius? The way you solve this is you take a look at 60 degrees Celsius and you bring yourselves up. Up here, it looks like this can only dissolve about 5 grams. This can dissolve about 20 grams for every 100 grams of water. Obviously, as you go higher and higher, you're finding something that can do more and more. And there we go right there. That's the highest thing on this particular graph, which happens to be, let's see, sodium biarsenate, if I read that right. So there's the correct answer. Okay. We go on to the next one. Which salt shows the least change in solubility from 0 to 100 degrees Celsius? A little wait time. All right, if you remember geometry class, you're looking for the one with the least slope, or the smallest slope. Happens to be the fuchsia colored line right here. Okay, it looks like it starts out at about what? Probably about 36 grams over here. And over here it looks like we get up to just about 40 grams. So the difference seems to be a difference of only 4 grams for every 100 grams of water. Okay, so that's 4 grams for every 100 grams of water. That seems pretty straightforward. Sodium chloride was the answer. What compound shows a decrease in solubility as we heat it up? Little wait time, and if you remember from math class, geometry class again, we're looking for a negative slope. If we're looking for a decrease, it's really easy to see here that this is a negative slope, so this cerium sulfate happens to be a good one to pick. And then also, it looks like this dark blue line, it goes up and then it bounces here and becomes less soluble as the temperature increases. Now, this is a slightly weird thing to do. Sodium sulfate is kind of odd because most things, if they're going to increase, continue to increase. They don't decrease all of a sudden. Something that I wanted to point out real quick on this last slide, be careful about how you read these. You want to be very careful. You notice that we have a certain amount of precision that we can read. We've got, it looks like the first and last sig fig that's here is in the tens place, so we need to guess to the ones place value. So we need to guess that 36. We couldn't, for instance, guess 36.5 because we don't want to guess 2 digits worth of precision there. We only want to guess that 1 digit. All right. New question. All right. New question here. What is the solubility of sodium chloride at 60 degrees Celsius? So we take 60 degrees Celsius, we mark our way up, and we see here that it crosses the line. It joins the 60 degrees Celsius right here, which appears to be, what, maybe 38 grams right there. So we'll write that in. 38 grams for every 100 grams of water. Now this is the solubility. You want both terms. You want the salt term and you want the water term. So you want 38 grams for every 100 grams of water written down. Something else to talk about here. I don't remember what it is though. We'll come back to it if we need to. Oh, I do know what we need to talk about here. Basically what this is telling us, this graph, this is telling us by reading the graph, this is what a saturated solution is going to be. So since it can hold 38 grams exactly at 60 degrees Celsius in 100 grams of water, that's going to be what a saturated solution is. If instead I only put in, the problem told me that I only put in, this looks like it's 26 grams, I would call this solution unsaturated at this temperature. Okay. Making a supersaturated solution, again, requires that we heat the solution up and then cool it down. So we'll talk about that in a few minutes, okay? How much sodium chloride could be dissolved in 100 grams of water at 80 degrees Celsius? Well, take care of this. Sorry about that. All right. How much sodium chloride could be dissolved in 100 grams of water at 80 degrees Celsius? Well, here we take a look at this 80 degrees Celsius. We read our way up and we find sodium chloride, and it looks like we're going to call that 39 grams for every 100 grams of H2O. Okay. Another question, how much salt could be dissolved in 200 grams of water at 80 degrees Celsius? All right, 80 degrees Celsius. Hey, we know that one. We just did it. It's 39 grams per 100 grams of H2O. Well, it looks like that's 200 grams of water. So if we double the water, what do we have to do to the numerator? We have to double it also. So that's 200 grams of water for 78 grams of H2O. Now, some people like to work it out this way. They like to say that you get 39 grams for 100 grams of H2O. So that's sodium chloride on top. And they like to put it this way. How much salt can you put in 200 grams of H2O? Okay, so we do 200 times 39. It's basically cross multiplication for math. 200 times 39 is equal to 100 times x. So let's see, 2 times 39 is, I just did that, didn't I? 200 times 39 is 78. Add 2 zeros, and is equal to 100x. Divide both sides by 100, like they teach us in algebra class. What you do to one side, you have to do to the other. That cancels itself out, and we get 78 grams being x. It's the same exact answer that we just had, right? 78 grams, 78 grams. Okay. Now, if the saturated solution of sodium chloride is made up at 80 degrees Celsius, and it's cooled to 60 degrees Celsius, what does it look like? Now, that's an interesting question, isn't it? So, let's see, at 80 degrees Celsius, we got to set this up. There's 2 actual things to do. All right, so at 80 degrees, oops, we started at 80, so I should write that over. Oops. All right, so at 80 degrees Celsius, we were able to hold 39 grams of sodium chloride. Quick little drawing here. We've got 100 milliliters, which is 100 grams of H2O, and we dumped in this 39 grams of sodium chloride. You stir it around, what does it look like? It looks like salt water. There's no salt at all on the bottom of this container, okay? So then at 60 degrees Celsius, I think I remember that I said that there was 38 grams of sodium chloride according to that graph. So the question is, what's going to happen when I cool this down from 80 degrees to 60 degrees, what's my new picture going to look like? Well, if I do this slowly, I'm still going to have 100 milliliters of water, and it's going to look exactly the same. The difference is this. This is a saturated solution. This solution here still has 39 grams of sodium chloride in it, even though it's only supposed to be able to hold 38. That's supposed to be able to hold, but it's holding 39. So I'm going to call this super saturated, just like yesterday's demo with the sodium acetates. Now, something about supersaturated solutions that we learned yesterday is if you disturb them, you can get them to crystallize the part that they can't hold anymore. So a simple way to do that would be to take one tiny little piece of salt and allow that to fall in there. That would be enough to disturb a supersaturated solution and cause it to start crystallizing. Only the part that doesn't want to be held is the part. Only the part that can't be held is the part that crystallizes. So the question becomes, how much would crystallize so that it's not supersaturated? Well, the math problem looks something like this. 39 minus 38 grams. 1 gram cannot be held. So what's going to happen is I'm going to wind up with salt crystals that equal exactly 1 gram. That's about all for today. There's 2 worksheets to work on. Saturated Solutions 1, which I provided an answer key for, and everyone got to see. And Saturated Solutions. Solubility Curves 1, which everyone got the answer key for. And then Solubility Curves 2, which I assigned as homework and graded as a quiz. All right, good luck.